All right, guys, welcome to polynomials. In this section, this first video, we're gonna be talking about adding and subtracting polynomials, and there's two parts to this. This is part one. So you won't see the adding and subtracting right away. We're gonna kind of set up what polynomials are, how to simplify them, and then we're gonna get into the adding and subtracting portion. So, number one, polynomials are a special kind of algebraic expression. So we're going to keep that in mind. We're going to kind of define what that algebraic expression is in a little bit. First definition is a monomial. Okay, a monomial is a single term. A monomial is an expression that is the product of a real number and variable raised to a non-negative integer power. So a monomial is a single term. Mono, like mono y mono. Okay, but there's a couple things. You have to have a real number and a variable being multiplied, and if those variables have to be raised to non-negative powers. Okay, and they have to be integers. So you can't have a polynomial that's x to the 1/2. Okay, because 1/2 is not an integer. So here's some examples. We have 8n cubed. So there's your real number. There's your variable being raised to a non-negative power, and it's multiplied. Okay, so it matches the definition. Again, 4/5, that's a real number. X being multiplied to x, and x is a power of 2, so that matches, right? Real number and a variable, okay, they're being multiplied, that product, okay, into a non-negative integer power. Negative 2p squared q5, q to the 5th. Well, here's three different pieces being added. Negative 2, that's a real number. Here are your two variables, p and q, both raised to non-negative powers, and that's good. And the last one is 12. And you can just write 12 as 12 times x to the 0. 0 is non-negative and 0 is an integer. So 12, the number 12, would also be a monomial. Okay, so again, like I said in the first slide, a polynomial is a special type of algebraic expression. Specifically, a polynomial is an algebraic expression with one or more monomials being added or subtracted. So we have a collection of monomials here, okay? So let's look at some examples of what's a monomial, or excuse me, what's a polynomial, what's not. So here now there are three monomials, okay? And we're raising those to a power of 2. Okay, power of 1 and then power of 0, but those are monomials. Each matches a definition, and there's a collection of them being added or subtracted. This is a polynomial, 3t squared minus 5. Okay, that's a polynomial. Negative 6.3x squared, that's a polynomial. Remember, negative 6.3 is a real number times a variable raised to a power. Okay, this is a monomial, but it's also a polynomial. X minus 1 over 3. Now this one's tricky. You could actually rewrite this as 1/3 x minus 1/3. So again, that is a polynomial. It's a combination of one or more monomials being added or subtracted. 5pqr minus 2p squared plus 5. That again is a polynomial. And the really key here is to watch the powers, especially. All my powers are positive, 1, 1, 1, and squared, okay? They're all being multiplied, okay? When you get into the division and negative numbers, you'll see what are not polynomials. So let's look at some non-polynomials. 5x to the negative 2 minus 3. It looks like a polynomial, but the power is negative. That is not a polynomial. And in the second part, n squared over 4, that would be a polynomial. 1/4 n squared. Negative 2 is a monomial. However, here's the problem right here, the 1 over n. That's also the same as n to the negative 1. You can't have a negative power in a polynomial, so this guy is not a polynomial. 5 root x is the same thing as 5 times x to the 1/2. That power is not an integer. 1/2 is not an integer. This is not a polynomial. And lastly, x minus 1 over x squared plus 3. This is what we call rational. This is not a polynomial. And later you'll discover and you'll ask yourself, can you write the polynomial, or whatever terms you have, as a sum or a difference of monomials? And these can't be written as a polynomial. So these are the non-examples of polynomials, and these are our examples of polynomials. Now, in this example, I'm just giving you a couple of parts here. Determine whether each expression is a polynomial. So I've given you an A and a B here. In part A, 6y squared minus y plus 5. Is that a polynomial? Well, if you look, And you see the variables are all raised to integer powers, so that's good. Non-negative integer powers. So in part A, this is actually a polynomial because it can be written as a sum of monomials. Remember, that's what a polynomial is. The sum of monomials, or the difference of monomials, right? So 6y squared minus y and 5y to the 0. Those are all monomials, and they're being added or subtracted. So we're good there. That is a polynomial. In part B, this expression cannot be written as the sum of monomials. And for example, I just rewrote 3 over, well, that probably won't work there. What will happen here is if we have that power in the denominator and we try to bring up the whole denominator, 2x plus 1 to the negative 1 power, you're actually going to have a negative variable. We cannot write this as a sum of monomials, so part B is not a monomial. Or excuse me, not a polynomial. Now, when you classify polynomials, there's 3 ways to do this. The most common are by the number of terms and the degree, but this first one I thought is really important. It's the number of variables. Sometimes you'll hear that expression, oh, in one variable, in 2 variables, and so it's really, we really haven't defined that. So a polynomial such as 3x squared minus 6x plus 9 is said to be in one variable because there's only one variable. There's just x in that collection of terms. A polynomial is such as 3x to the 4th times y minus 5x squared y cubed plus 9 is said to be in 2 variables because there's 2 variables here. Now, it doesn't matter if just the first term had x, y, and the other terms didn't. It would still be in 2 variables because there's 2 variables in that expression somewhere. Okay? The most common way is by the number of terms. Okay, that's another way to classify polynomials. So you have 3 different types, really. You have monomial, which we've talked about, a single term. Binomial, which you've seen with quadratics when we multiply binomials, those are 2 terms. And trinomials are 3 terms. So I just gave the example, 8x squared is a monomial, 1 term. A binomial is really adding 2 monomials together, and a trinomial is adding 3 monomials together. So a trinomial is like x squared plus 4x minus 7. You've seen these. When we talked about linear functions, those were most of the time binomials, trinomials when we studied quadratics. Now, it's key that you get, how many terms there are by mono, there's 1, bi, that's 2, and tri, by, it's 3. Anything after 3, we just say it's a polynomial. There's no name when we have 4 terms or 5 terms. So I want you to keep that in mind. Lastly, the way we classify polynomials is by their degree. And it's based on the highest degree of any of its terms. For a this one's a key note here. For a polynomial in more than one variable, its degree is the sum of the variables, or sum of the powers, on its variables. And we'll see an example of that. And so here's an example in part A. This is a polynomial, okay? It's a collection of monomials. There's no negative powers. There's no fractions where x is in the denominator. Okay, so here's a polynomial. It's in standard form, meaning we start with the largest power and work our way down. And the largest power on our variable is 3. So this would be called a degree 3 polynomial. Part B deals with this example right here, and this is really important. I have 5x squared y to the 4th. So that's a polynomial in 2 variables. So how do you determine the power? Well, you could say, like we did here, oh, x is cubed, so it's squared. That's the degree would be 2. It's not. You have to take the sum of these powers. So 2 plus 4 is 6. So this would actually be called a 6th degree polynomial. Okay? And that's examples dealing with this bullet here. That's very important. All right, in our last slide, we're actually going to classify each polynomial, then identify its degree. So in blue here, I've given you 4 polynomials, okay? And so in the first one, in part A, there's 1, 2, 3 terms, okay? And the largest power on P I see is 2. So in part A, the solution would be a trinomial of degree 2. In part B, You want to be careful. Some people would run right to this minus 3x squared and say, oh, the degree is 2. So this is a polynomial, but it's not in standard form. We have 7x minus 3x squared plus 21x plus 2x cubed. The cubic is the largest term back here. So in part B, this is a polynomial of degree 3. And notice I said polynomial, not trinomial or quadnomial, because there's 1, 2, 3, 4 terms. But remember, anything after 3 terms, we just call it a polynomial, and that's of degree 3. Part C, just a constant there, it's negative 18. That's a monomial, and that's degree 0. Okay, because you could throw a x to the 0 power, and we know that anything to the 0 power is always 1. But that is a monomial of degree 0. I saved the trickiest one for last here in part D. We have m squared n squared minus 3mn. So it's a polynomial in 2 variables. So here's what we have to do. We know that it's one term minus another, so it's a binomial. That's pretty self-explanatory, hopefully. But now how do you find the degree? We have m and n, so you have m squared n squared equals 2 plus 2. That's degree 4. Then we actually have to look at the 3mn term. Okay, and that's degree 1, so that's 2. Okay, so you got to be careful. We don't add these two together to get 6. Remember, we take the highest degree on our variables in the polynomial. Well, the highest degree here is 4. The m squared n squared has the highest power, sum of powers. Okay, so that is a 4th degree binomial. Okay, so that's classifying and identifying the degree of polynomials. Now, we didn't add or subtract. That's now going to be in video 2. If you guys have any questions or comments, just type them below, or you can email me at nicholas.bennett@dc.gov, and we'll see you next time. Thanks.